So when studying relations, there are three very important properties that we want to become used to studying. We're going to be doing proofs on them. We're going to be looking at examples, but there's three things that really drive the progression of relations. So if we start out with A being a non-empty set and R is going to be a relation on A, these three definitions we're going to look at are reflexive, symmetric, and transitive. So reflexive, so the relation is going to be reflexive if A, comma A, this ordered pair is in R for all A. Or in other words, what this is saying is that A is related to itself for all elements in this set. So every element is related to itself. Symmetric says that if A is related to B, or if A comma B is an R, then B comma A is also an R. So in other words, we're saying that if A is related to B, then B is related to A. And that has to be true for all of these pairs. That as long as this is true, then the opposite way. So this is somewhat of that, I mentioned this commutative idea. So we can't always switch things, but we can switch things when you have a symmetric relation. And then the last one is transitive. So this says that if A comma B is an R and B comma C is an R, then A comma C is also going to be an element of R. So this is saying that if A is related to B and B is related to C, then A is related to C. So maybe you've seen the transitive property in action in other ways, that if one implies something, that implies something else, then the first is going to imply the last. Okay, so these three, reflexive, symmetric, and transitive, are important. So let's take a look at this example. So if we have the set A as the set containing 1, 2, 3, and this relation is defined as the order of pairs of 2, 2, 3, 3, 2, 3, and 3, 2. Is this reflexive, symmetric, and transitive? So reflexive, so we're saying for all of these elements, is that number related to itself? So we could ask, is 3 related to 3? Yes, it is. Is 2 related to 2? Yes. Is 1 related to 1? It is not. So this here, this is not reflexive. We see that 1 is not related to 1. So we do not have every element related to itself. Now for symmetric, we have to say that if we have a relation in one of these pairs, that we could flip them, and that's still going to be in there. So if we look at this, that if we take a look at 2 2's in there, well, if we flip that, 2 2's also in there. Cool. 3 3's in there. If we flip it, 3 3's also in there. That's great. 2 3. If we flip it, is that in here? Well, yes, 3 2's in there. Same thing as 3 2's in there. If we flip it, is that also in there? Well, yes, 2 3 is in there. So this is going to be symmetric. And then the last one, transitive then. So if we basically think about going on a trail, so if we think, okay, 2's related to 2, 2's related to, so 2's related to 2. Okay. 2's related to 2, 2's also related to 3. Is 2 related to 3? Well, yes, 2's related to 3. We think about 2, well, is 2 related to 1? Well, no, it's not. So we don't have to think about any scenarios of 2 being related to 1. Same thing here. Now if we think about 3, well, 3 is related to 3. And then we think about then, is 3 related to anything else? Well, 3 is also related to 3, so 3 is related to 3. And 3 is related to 3. 3 is related to 2. Is 3 related to? Well, yes. So this is also going to be transitive. Now, with some of these instances, for instance, that transitive idea may have just been really confusing to you, and that's okay. We're going to do plenty of other examples to have some of these make sense when it's going to be a little bit of a larger set or something a little bit more abstract. Okay, so that's at least our first example of looking at these three. Now here, this is one of my favorite relations, is so we have the set of all people. Then we define this relation by saying A is related to B. So the relation is actually related. So you are related to other people, and other people are related to other people. So we'd like to understand, is this idea of related actually a reflexive, symmetric, or transitive relation? So we could look at reflexive. So are you relate? So for every person, is that person related to themselves? So are you related to yourself? It's a weird idea. Am I related to myself? you could have some good questions on that, but I will say yes. I will say that this is one of those like vacuously true things where it's just like, yeah, we'll just say that you are related to yourself, right? You share DNA, you share the same types of things with yourself, so we will say that this is reflexive. Now, symmetric. So we think about, okay, symmetric. So if you are related to someone else, is that person also related to you? So think about all of the weird scenarios you can think of. Okay, so you could say, okay, well, I am related to, say, my dad. Is my dad related to me? Well, yes. I am related to my sister. Is my sister related to me? Yes. And so you can seem to always be able to switch the direction. So this seems to also be symmetric. Then transitive. So again, start to think through what does it mean to be transitive. So you kind of create this line of one is related to this person is related to this person, is this person related to this person. So again, you start to think through some examples and say, okay, well, let's see. So maybe I am related to my brother's related to my sister. Am I related to my sister? Well, yes. Okay, then, well, let's see. So maybe my mom is related to me and I'm related to my sister. Is my mom related to my sister? Well, I don't know, maybe. That one gets a little tricky. What about maybe grandparents, for instance? Let's say I'm related to my mom is related to my grandma. Am I related to my grandma? Well, yes. But what if we think about another example? So if we think about my dad is related to me, I am related to my mom. Is my mom related to my dad? Well, I guess hopefully not, right? I guess, there are weird situations. I mean, there's some states where that's more normal, but the idea of our parents being related, I mean, it's not really the way we think about related. Now, obviously, we could get very big picture and say, well, technically we're all related then because we all share some DNA with each other. Okay, that's fine. But I just mean like the normal idea of related to each other in the way that we think about it. So this is going to be not transitive. Because indeed, it has to be true for every possible situation. So it's not transitive. So for instance, so I will say here, Pete is going to be related to his mom. And we also have that that we have, oops, wrong order. So my mom is going to be related to me. And then we also have that me, or I, am related to my dad. But we do not have that my mom is not going to be related to my dad. And that was another one. So when it came to the siblings one, that's where things could get a little bit dicey about if you have, say, half siblings or I guess that probably, or like step parents. Some of that again could be a little bit tricky of, again, it's not going to be true for all situations. So this idea of related from a human standpoint, this is going to be reflexive and symmetric, but it is not a transitive relation. So we'll take a look at some number ones, because sometimes the numerical ones that we're used to in math might be a little bit easier for us to have some clear, defined rules and regulations on those.